Alright, 17.12. Determine the angular acceleration of this spool. And the spool has a mass of 8 kilograms, a known radius of gyration about g, which is our k value of 0.35 meters, has distance units. Try to remember that. And the chords are negligible mass and wrapped around the inner hub and the outer rim. So the thing is being supported here by this chord at A, but it's also got this force pulling it up. So this thing is probably going to have some alpha in this direction, but we're still going to call this the positive direction, like normal. We know what this force is. It's 100 newtons. We know the radii. The inner radius is 0.2 meters. The outer radius is 0.5 meters. All right. What kind of forces we got on this thing? Let's say we got some mg going down. We have some tension at A, some force already drawn on there for us. And let's go ahead and sum the forces in the y direction, see what we get. So that equals the mass times the acceleration of the mass center in the y direction. I have a tension at A pulling up. I have a force pulling up. I have a mass times gravity pulling down, and that's going to be equal to the mass times the acceleration of g in the y direction. We have no forces in the x direction, so we're not going to have an acceleration in the x direction. What we get from this, TA plus the known 100 newtons, we can calculate mass times gravity, 78.48 is equal to 8 kilograms times the acceleration due to gravity. Also, something we should actually do real quick is calculate I. If you're given K, that means just go ahead and calculate I right away. It's 8 times 0.35 squared, and we get a 0.98, and we get units kilogram meters squared. Alright, we're going to need that, because next we need to sum the moments. So summing the moments about g gives us Ig alpha. Oh, that's not alpha. Ig alpha. What kind of moments do we have about g? It's our mass center. Well, looks like we have a T at A, this guy, pulling up. That would cause it to rotate. That's a moment. So TA times the acting distance is a 0.5 meters. That's our perpendicular distance. And I gave it a positive sign because convention. I'm going to give the next one a minus sign, and that's due to this force, because if this force acted alone, it would definitely rotate in the negative k direction. So it's a minus F times 0.2 meters. And we know I now as 0.98, and we're looking for alpha. Okay, one more equation. There's 1, 2. I would ask you in class for what it is, but we're looking for the acceleration of g is equal to r alpha, and we can say the acceleration of g, we would use the 0.5 meters for r, and there's our equation number 3. 1 into 2 into 3 gives us an alpha of negative 10.3 radians per second squared. Alright, you can also, let me redraw this real quick. We had a force acting here. This was TA acting right there, and mg pointing down. Okay, we can do this about A. This is solution number 2. Let's sum the moments about A. And that's our instantaneous center of zero velocity in this case. We're still going to use the acceleration of g is equal to 0.5 alpha, because that's our 0.5 from our point A. And the reason we need that is because when we sum the moments about A, that'll equal our summation of our kinetic moments about A. And I'm going to go ahead and do the right side, because the reason we need this is because we use I about G times alpha. That is about the mass center G. But we have to include the kinetic moment, which is the mass times the acceleration G times 0.5 meters. So this thing you should see is your force, and this is your acting distance, which would give you a moment. Alright, now what moments do we have on the left side about A? We have mg pointed down and our force pointed up. So the force pointed up is the minus 100 newtons, and it acts at 0.5 meters. And wait, I'm just checking my dimensions. 0.7 meters. We have to add this distance plus this distance. 0.5 plus 0.2 gives us 0.7 meters right there. Ha ha ha. Alright, so check your dimensions. And then the other force is the mass times gravity pointing down. That would cause us a positive rotation, so I'm going to keep a positive sign. 78.48 we calculated before, and it's acting at 0.5 meters away. Okay, we have everything now. We can solve for alpha as negative 10.3 radians per second squared. Thank you.